Okay, so today we're going to be talking about solving multi-step equations. You've probably learned this in previous classes, so this is going to be kind of a flyby review. We do need to know some key concepts. The first one is an expression and the difference between an expression and an equation. So an expression is numbers, symbols, and operators such as addition or subtraction grouped together to show the value of something. So there is no equal sign in an expression. An equation is a mathematical statement that two things are equal. It consists of two expressions, one on each side of the equal sign. So please understand the difference between an expression and an equation. So we are going to be solving equations. And so you can't necessarily solve expressions, you can simplify expressions. So we also need to talk about inverse operation. So inverse means opposite, so you got to do the opposite operation. So I'm sure you've learned this before. The opposite of addition is subtraction, the opposite of multiplication is division, and vice versa. So we're going to use that in order to help us solve these equations. So the first one, so using inverse operations to solve each equation, then check your answer. So the first thing that we want to do is distribute if necessary. So if there's a set of parentheses that requires us to distribute, we want to do that. Or simplify. This can also be simplify. Okay. The next thing we want to do is if there's a variable on both sides, you want to move it to one side. Okay, and I'll show you what I mean with that in just a second. After you've done those two things, then we come to the inverse operation. So the first thing you will want to do is you will want to undo your addition or subtraction. So that's what you want to do first. Then you undo your multiplication or division. Okay, so following these steps will basically solve any equation. So if we look at number 1 here, so we have x plus 4 is equal to 12. So we don't have anything to distribute or simplify. We don't have a variable on both sides of the equal sign. So now we come to undoing addition or subtraction. So here we have addition, so the opposite of addition is subtraction. Now what I like to do is I like to draw a line straight down the middle of our equal sign here. I call these railroad tracks. What you do on one side of the equal sign, you must do on the other, so it has to be balanced. So if I want to undo this addition, I'm going to subtract 4. And what I do on one side, I have to do on the other. So these will actually cancel out. All I'm left with is the x, which is equal to, now 12 minus 4 is 8. And that's your answer right there, x equals 8. Now to check, which this is a huge important thing, to check, you just plug in your answer back into the original equation where x was. So our x is equal to 8, so that's what I'm going to substitute there. And I just plug it into the equation. Well, does 8 plus 4 equal 12? Well, yeah, it does. So we know that our check is right, or our answer is right. If we look at number 2, we have 12b equals 18. So again, I'm going to draw my line representing my railroad tracks. So I don't have anything to distribute. I don't have a variable on both sides of the equal sign. I don't have any addition or subtraction, but I do have multiplication. So what is the opposite of multiplication is division. So I am going to divide both sides by 12. Now these will cancel out. 12 divided by 12 is 1. So I'm just left with b is equal to 18 over 12. Now, in Algebra 2, we really don't like to turn those into mixed fractions. So what I'm going to do is I'm just going to simplify or reduce. So 18 over 12, those can both be reduced by 6. So 6 goes into 18 3 times, 6 goes into 12 twice. So my answer is 3 over 2. Now to check this, again, we plug it into our variable. So I have 12 times 3 over 2 is equal to 18. Now if we're multiplying fractions times a whole number, you can change that whole number into a fraction just by putting it over 1. Then to multiply fractions, you multiply straight across. So 12 times 3 is 36. 1 times 2 is 2. And that's equal to 18. Well, 36 divided by 2 is in fact 18. So it works. Now number 3, we do have some distribution that can happen. So I can distribute this 1/3 into both of those. Okay, so there's actually a couple different ways that you can do this. I'm going to show you one way right now, and then I'll show you another way here in a second. So I'm left with negative 27 plus 6y, I'm going to draw my railroad tracks, is equal to 1/3 y minus, now 1/3 times 3 is just 1. Okay, so now I have this awful fraction here, this 1/3 y. What you can do is you can do a couple of things. First thing, you do have a variable on both sides of the equal sign, so you need to get it over to one side. So what I like to say is numbers on one side, variables on the other. So what I'm going to do is I'm actually going to add this 27 to both sides. So that leaves me with 6y is equal to 1/3 y plus, well, negative 1 plus 27 is 26. This is where we can split it up and do this two different ways. If you really like to work with fractions, which it's totally fine, you can subtract 6 minus 1/3. So this is the first way. We can subtract 1/3 y from both sides. So 6 minus 1/3, if I turn 6 in and have a common denominator, got to multiply by 3. So I get 18 over 3 minus 1 over 3, which is equal to 17 over 3. So subtracting 1/3 y will give me 17 over 3y, which is equal to 26. Okay, so now we can get rid of our, so we already got rid of our addition and subtraction, that was the plus 27, so now we got to get rid of the multiplication and division. So really what this 17 over 3y is saying is that it's 17 times y all divided by 3. So the first thing that I want to get rid of is I want to get rid of that divided by 3. So to get rid of that, you multiply. So I have 17y is equal to, well, 26 times 3, let me see, what is that? 78. And then you get rid of your multiplication here, so I divide by 17. So that means that y is equal to 78 over 17. And I checked, and that does not reduce. It's an ugly, ugly fraction. But we have to learn how to deal with these ugly fractions. Okay? So that's one way to do it. The second way to do it is, I'm just going to scoot this over. Is I can get rid of that fraction right off the bat. So if I want to get rid of the the denominator of 3, remember it's just dividing by 3. So to get rid of it, you multiply by 3. And what you do on one side, you do on the other. So that means that 3 times 6y, well that's 18y, is equal to, so this really just distributes, 1/3 times 3 is just 1, so just y, plus 26 times 3, we said was 78. So now I don't have any fractions whatsoever. Now I can just move my variables to one side. So I'm going to subtract the y. I get 17y is equal to 78, and I land right back where I did over here, divide by 17, and y equals 78 over 17. Okay, so get comfortable with these ugly fractions. Okay, looking at number 4, I had to erase to make some room. So looking at number 4, I want to distribute first. Okay, so 3 times 2x, well that's 6x, minus 3 times -1 is 3. So I have 6x minus 3. Now over here, whenever you distribute, make sure that this negative sign goes with it. So -2 times 3x is -6x. -2 times +4 is -8. And that equals 11. So now we need to simplify some things. We need to combine like terms. Well, we have this 6x and -6x, and then we have the -3 and then the -8. Well, 6x minus 6x is 0. Okay, so those actually cancel out. -3 minus 8 is -11. Now, does -11 equal +11? No. So if you get a statement here or an equation that is untrue, your answer is no solution. That means that no matter what x value I plug in, this equation will never work. Okay, so looking at number 5, so we don't have anything to distribute, but we have some like terms that we need to simplify. So my like terms here are going to be the 11 and the -7. So I have 3x, so 11 minus 7, let's see, 7 isn't 4. And over here I have 6x minus 3x, so that means I have 3x plus 5. Okay, now some of you can already see where I'm going with this. I have variables on both sides, so I need to get rid of them. So I'm going to draw my railroad tracks. Subtract 3x on both sides. I'm going to take all of that. That cancels and that cancels. And all I'm left with is 4 equals 5. Well, does 4 equal 5? No. So if it's an untrue statement, it is no solution. Okay. And last but not least, number 6. I'm going to draw my railroad tracks here. Again, you have some things to simplify. On the left, you have 6x and -2x. So that gives you 4x plus 5. Okay. And over here, I have 4 and 1. So I have 4x plus 5. Now right here, you have the same thing on both sides. Okay? So if you try to move something to one side or the other, it's all going to cancel out. So if I try to move over the 4x, that cancels, and I'm left with 5 equals 5. Well, is that a true statement? Well, yeah, 5 does equal 5. So if it's a true statement, it means that there's an infinite number of solutions. So I can plug in any value of x, and it will be the same on both sides. I can plug in 1,000,000, and it will work. Okay, so that's what it means by an infinite number of solutions. So your job is to try out these practice problems. It's actually your assignment. So try those out. and let me know. Last but not least, we have this word problem. So flower carpets incorporate hundreds of thousands of brightly colored flowers, as well as grass and tree bark, and sometimes fountains to form intricate designs and motifs. The flower carpet shown here from the Grand Place in Brussels, Belgium, has a perimeter of 200 meters. What are the dimensions of the flower carpet? So you've been given some information in this picture here. You've been given that the length of this guy is 3x and that the width of this guy is x. So you have length is 3x and your width is x. So if you remember back in, I don't know when you would learn this, but probably elementary school somewhere, that perimeter, especially of a rectangle, is 2 times the length plus 2 times your width. So if you have a perimeter, you already know that it is 200 meters, so that's what's going to go over here. You have 2 times your length. Well, what's your length? We said that that was, what was it, 3x? Yeah. Plus 2 times your width, which is x. So this is how you set up your equation. So now just simplify. I have 200, well 2 times 3x is 6x, plus 2x. So that means 200 is equal to 8x. Now we need to solve for x. So I don't have addition or subtraction, I have multiplication over here, so I'm going to get rid of it and do division. Well, 200 divided by 8 is 25. So 25 is equal to x. Now, read your question carefully. It does not ask what is x. It says what are the dimensions of the flower carpet. So now that we have found x, we can plug that in to our length and width. So if our length is 3x, then that means that we have 3 times 25, which is 75, and our unit is meters. If our width is x, that means that our width is 25 meters. So there are your dimensions. Anytime you're given a word problem, be sure that you are answering the question that is asked. Okay? And again, you have a practice problem here. Also down at the bottom, you have an SAT practice. It is a question taken from SAT Prep. It is also part of your homework. If you have questions, let me know.